as our solving systems by substitution goes, you just have to remember that substitution means we're going to replace it. So like today, your two equations will look like this. You'll have like y equals 3, and then you'll have something like, there we go, 3. Then you'll have like y equals 2x plus 7, and it'll be your job to remember how to substitute. So if you remember, if we know y is 3, there we go, y is 3, that means we can replace this y down here with 3. So it's just going back to replacing. So down here, I'm going to replace this y now with the value of 3. Get 3, come on, pen, 3 equals 2x plus 7. And now it becomes an equation. So we got to solve this equation for x. So if you remember how to do that, what we're going to do is we're going to first have to transpose our plus 7. Try that again. Transpose our plus 7 over here, make him a minus. So it'll be 3 minus 7 equals 2x. And now 3 minus 7 is negative 4 equals 2x. And now last one to solve for x, if they're side by side, that means they're being multiplied. So the reversal of that is to divide. So divide both sides by 2. And negative 4 divided by 2 is going to be negative 2 equals 2's cancel. And we just left with x over here. Now what makes this different from a regular old equation after we substitute is the fact we have to write our answer out in a specific way. So like how with the solving systems by graphing, we wanted to write the point. We want to write this value as a point. So your x value always comes first, and we said that x equals negative 2, and that our y is going to be 3, so y is 3. There we go. The next one, we'll do that one in purple. It's like if we have ones that have 2 variables in them. So like we have 3x plus 2y. There we go. Equals 9. And if we have y equals a negative 2x. So if you look at it, we're still substituting, which means we're still going to have to figure out what y is. So if I know y, I want to change over to green again. There you go. Y is negative 2x. And that means we can replace this y up here with the negative 2x. So I'm going to drop down my first equation and just write 3x plus 2. And because 2 and y are side by side, that means they're being multiplied. So 2 times, and now we said y was going to be negative 2x equals 9. So now we just use order of operations to simplify it down. So we're going to do 2 times negative 2. So we'll do 3x, and now 2 times negative 2x is going to be a negative 4x equals 9. Do 3x minus 4x, and we get negative 1x. Equals 9. The last step we got to do is divide both sides by negative 1. Negative 1's cancel. We end up with x equals negative 9. So once again, after we substituted, it just became a simple equation. All we had to do was multiply, combine our like terms, and then divide. This one that has one extra step, because if you remember, I need to write my order pair x, y. So I know x is negative 9. But for this one, it just says y equals negative 2x, and I need that to be an actual number. So we're going to rewrite out to the side here, y equals negative 2x. And if you remember, x is going to be negative 9. So now that I know x is negative 9, I can replace this x up here with the negative 9. So we're going to say y equals negative 2 times negative 9. Now negative 2 times negative 9 is a positive 18. There we go. And last step again is to write our order pair. So we have our x comes first, then our y. So our order pair, x first is going to be negative 9. And then our y second is 18, so 18. And we're all good. And this brings me to like my next point that I always like to make with these. It's always better to solve by substitution with some of them because this would be really hard to graph. Like, who wants to go left 9 and then up 18 to find a point of intersection? That's a really big graph you would need. Oh, so it's really nice to be able to solve them by substitution and not have to make crazy big graphs.